Okay, then we'll get started. My name is Bart Ney. I'm the Senior Communications Manager for the California Department of Transportation, spokesperson for the San Francisco-Oakland Bay Bridge. And today we have invited the media out to give you an update on construction progress for our new bridge. A number of things are happening right now and will continue to happen over the next 2 years as we get ready to open up the new bridge to public service. First and foremost, we have a steel transport ship that has recently arrived carrying our final deck segments that are going to be put in place over the next couple of months to complete the main deck for our self-anchored suspension bridge. We also, over the past few weeks, have constructed a catwalk system that is very visible to the public that is going to act as a platform for our construction teams to erect, to basically place the main cable of what will be the world's largest self-anchored suspension bridge out in three-dimensional space. So that's another very visual element of the project that continues. As we get closer to the end of the year, we will begin erecting equipment that is going to be placed out there, basically what will look like a giant ski lift. Large conveying machine that will pull the cable strands all the way across over what you see out there that is the catwalk system. So that work will begin, the actual pulling, probably January of 2012, but the equipment is being installed now. You'll get a chance to look at that out in the field today. On Yerba Buena Island, our contractors have been working long hours to ensure that the transition structure that connects the self-anchored suspension bridge to the Yerba Buena Island Tunnel is completed on time. So we have the westbound portion of that structure that would take you into San Francisco is nearing completion and should be done by the end of this year. And then we'll begin construction on the eastbound portion. It's already actually started, but you'll see concrete being poured early next year. And then coming in the spring of 2012, we will be completing an operation that started early this year. Earlier this year, we moved eastbound traffic to the south on the Oakland side of the Bay Bridge to accommodate for construction work that's going to be happening over the next couple of years. That will allow us to open the bridge all at once, approximately 6 months ahead of the original schedule. What we will be doing in the spring basically is closing the westbound bridge heading into San Francisco for a period of days. We'll be coming back to you with more information on that so you know exactly what will happen. This will be similar to other closures that we have done. While we are closed, we will be shifting the approach to the bridge. After you come out of the toll plaza, traffic is going to be shifted to the south. And that is going to allow us to be able to surgically remove a portion of the bridge that is currently in the way of the new bridge's alignment. So while traffic is running on this new portion of the bridge, we will remove that old portion, and that will allow us to put the construction crew there and basically let us complete the new bridge so we can open the entire thing at one time. This is a lot of information, I know. Again, you can go to baybridgeinfo.org to take a look at any other element of that. I'm about to go through a presentation that will break down what some of these operations look like. But before I do that, I want to say that tonight is also a special night. We're going to illuminate the construction lighting on the catwalk for the self-anchored suspension bridge for the first time. And most people might say, you know, big deal, it's construction lighting, and I think maybe our architect would say that as well. But what actually happens is it's a little bit of a reveal. The construction lighting is out there because our teams will have to work at night to place this cable, and they will need those pathways illuminated. But ultimately, what it means for the Bay Area is you're getting an early look at what this bridge is going to look like at night for the first time at 7:45 p.m. tonight. So we wanted you to be aware of that. Now, those are the main items that we have asked you here to see. This is one of the few times when we've been able to work out a point in time with our contractor where we could actually allow you to come out and be physically on the bridge and go up inside the tower as well. We're hoping you'll work with us today, follow all of our safety standards. There will be a number of Caltrans personnel to ask any questions of regarding safety or access. If you have any questions or need quotes, please see myself or Tony Anziano. Now, at this point in time, we'll go ahead and, Mike, do you have a quick one?
Yeah, well, you sort of asked, but why today? Just because the lights are going on?
Okay, let's take the Q&A. I'll run you through the presentation because it'll help some folks. This is their first time doing this stuff. Okay, so go ahead. Paul, are you ready? Okay, again, this presentation is available, all the elements of it are available online at our media bar. Mike, if you can, or maybe Sarah. This is just to help give you an understanding of the different elements that are ongoing for the Bay Bridge. So the first piece is the arrival of the final steel deck segments on a transport ship that came in yesterday on Sunday. And so here is some of the footage of the pieces arriving here in the bay underneath our western spans. There's over 5,000 tons of steel on this transport ship, and this is the last ship of its type that's coming in for the bridge. There's still a couple of hardware items that we're awaiting, but the bulk of the steel is now here. And what are we actually seeing today? Well, basically, if you look at the very end of the self-anchored suspension bridge, there's still a gap between that and the skyway. So over the next couple of months, these pieces that have arrived are going to be filling that gap. So here you can see, using Google Earth, we've outlined the gap that exists. These are the pieces that have recently arrived and need to be placed. So over the next couple of months, you'll see us in this order place segments 13 west, 13 east, 14 east, 14 west, bolt them and connect them into the bridge. Over 350,000 bolts are used to connect these entire deck sections. There are 28 sections overall. These are the final 4 pieces that will complete that deck. They're some of the most complex ones we've had to build for this bridge because inside of them is the anchorage of the structure. The cable actually connects inside. The next topic are the catwalks. So over the past few weeks, we've seen this happen, but in the 30s, that's when it happened for the first time. And you can see it's slightly different, the process that they use to put them in place. So this is vintage footage, but it's basically the same type of structure. Steel cables, steel sort of chicken wire mesh that the workers work on. We now have wooden platforms that are on top of that mesh, but you can see this guy struggling a little bit to get in place. Now these guys had to do some different things than we've had to do. But again, you can see right there that the catwalks create the geometry of the bridge. So in the 30s, when those came out, that's when Bay Area residents saw for the first time what the west spans of the Bay Bridge would look like. That is what you're seeing right now. So over the past few weeks, we put our catwalks in place. You can see here are a couple of still images of what you're going to see out on site today as they come in and connect to the top of the tower. This is our back span, the short span that heads towards Yerba Buena Island. And then also online, we've got a couple of quick snippets of I think this is some of the electrical work that was done to put the lighting system in place as we get ready to place the main cable. Again, here's a little shot for scale. You can see one person working on those catwalks. These lights are the exact same fixtures that were used on the Alfred Zampa Memorial Bridge over the Carquinez Strait back in 2002. American Bridge procured them and is using them out here. So when we put those catwalks in place, that was the preview of what that bridge would look like at night. Tonight, it's the same thing. So that's the catwalk placement. Upcoming milestones. The final deck segments installation, that's happening over the next couple months. These shots show a little bit of what some of their predecessors looked like. A very large crane-mounted barge, or barge-mounted crane that actually does the heavy lifting to put these segments in place. The segments weigh over 1,000 tons, are lifted into place and set down where they need to be, and then bolted together. So that's just a few quick shots of what the operation will look like over the next couple of months. And then as we finish the year, the hardware is going to be going into place for cable placement. As next year begins, we'll go more into actually placing the main cable. But what is the main cable and why is it different on this bridge? Well, this bridge is going to be the world's largest self-anchored suspension bridge. It only has one main tower and one cable. So if you follow these arrows, you can see cable starts on the east side, comes across traffic over the top of the tower, wraps around the back of the bridge, comes back across traffic up to the top of the tower, and then anchors back on the other side. if you think of a traditional suspension bridge as a hammock connected on two sides, this cable is more like a sling. It's connected on one side and it loops around the other. So if that makes sense, then we can show you sort of what the next process is. In order to put this cable in place, we have got connections that are going to be happening, well, primarily connections are going to be happening on the eastern side of the self-anchored suspension bridge, and the wraparound is going to be happening on the western side of the bridge. So we take a look at the eastern side first. You can see how the main cable comes down into the road that you drive on. And then, like any traditional suspension bridge, the cable fans out. Now, this cable is made up of smaller wires. If you look in your fact sheet, you'll see that there are 137 strands of 127 wires each. Now, those wires are about 5 millimeters in diameter. Each one could basically lift up a military-grade Hummer. And there are 17,399 of those wires in the main cable of this bridge. And so as it comes down into the deck, it comes through the shroud, and then it fans out and is tied back within that deck section. That's how it connects on the eastern side of the bridge. Now, if we look back here at the main span, the cable comes down, it wraps around the western side at Yerba Buena Island. Unlike traditional suspension bridges, where the two cables are moving in sort of two planes, just up and down, our one cable is moving in three planes. It's coming across traffic up to the top of the tower and then back across and wrapping around. So we have saddles that are angled on the back end of the bridge that receive that cable and bring it around. And then another saddle about midpoint where during construction we can work with the tensioning on the cable so that we get it where it needs to be for placement. And then again, on the other side, you have that same type of three-dimensional saddle that takes the deviation as it comes across. So hopefully that makes sense. It's moving in three planes. It's not coming straight down. It's coming at an angle and across. So that's what's happening on the western side. Then there are steel cables inside that beam that are holding down that end of the bridge inside some of the largest foundations of their type in the world. The cable, as I said before, is made up of strands of wire. 127 of those wires are in one strand. There you can see that hexagonal pattern of one strand. And then we have 137 of those strands that make up that main cable. And once they're in place, and we have the rest of the hardware on the bridge, the cable is then compacted into a cylindrical form. So that's how it ends up looking round, and you have this type of geometry happening. Now that's going to be happening the year beyond us placing the cable in 2012. And then, where are we going today? There. That is the top of the world's largest self-anchored suspension bridge. You can see that it's clearly both a part of Oakland and downtown San Francisco when you look at it from this level. That saddle that you see there that's empty today and we're going to fill over the next year is the largest saddle for any suspension bridge in the world. It weighs over 800 tons. Now, Yerba Buena Island, we have another project that's going to connect all of this back into the tunnel. And so here you can see the bridge has been designed, the new eastern span, with side-by-side traffic. The old bridge has got double deck. That means that as we come onto Yerba Buena Island, we have to reorient that traffic into a double deck configuration so that it can go through the tunnel and on to the west spans. So currently we have detour traffic onto the Yerba Buena Island detour structure. And right now we're building the westbound structure, which you'll get a really good view of today from the top of that tower, that will take the traffic heading into San Francisco off of the self-anchored suspension bridge and connect it to the top of the Yerba Buena Island tunnel. And then after that's done, we'll have the eastbound traffic that's heading from San Francisco to Oakland slide underneath that structure and connect into the tunnel on completely different foundations for seismic reasons. So you can see here, outriggers. They are what support the westbound structure. There is a different foundation for the eastbound structure so that these structures can move in a large-scale earthquake, and that's what this project is really all about. And these are a couple of shots which will become moot once you go up there, but it gives you an idea again of what you're going to see. These were taken from a helicopter or an airplane. And there's the westbound structure that is being cast right now. And you can see the columns down there below for the eastbound structure that we're getting ready to work on. And a shot from the platform of what it looks like to look back from Yerba Buena Island towards the self-anchored suspension bridge. So that's what's happening on the island. Then here in Oakland, there's a lot of work happening too on our Oakland touchdown portion. I talked about that detour earlier. I want to try and break down for you what exactly is happening here. So with this image, you can see that we have got a brand new, very bright white colored structure that is the new bridge with westbound traffic on the outside, more to the north. Eastbound traffic will be the one sort of in the middle, and the existing bridge is the one on the southern part. And here you can also clearly see that there is a conflict with the eastbound bridge. So that's why we've only built it that far. This is in the way. So that triangle has got to be removed before we can complete the bridge. So the strategy for being able to do this was earlier this year, we put in an eastbound detour. Basically took people heading into Oakland further to the south to clear space so that we can do this westbound detour that's coming early next year. So as you come out of the toll plaza early next year after we do this closure, we're going to be routing traffic slightly more towards the south to open this area up. And then that red triangle you see right there is what has to be surgically removed. It will be cut off so that we open up that area in the middle so we can put a construction crew in between the bridges and build it out at the same time that we're building all the rest of the bridge. That is what is allowing us to open this bridge all at one time. That's what's happening on the Oakland side of the bridge right now. And Paul, if you can, here's a quick animation. If you can follow it fast. This was the opening of eastbound and west. That's where we're going to be next year. Then take that section out, build the new bridge, and open up to traffic. If you can hold there, Paul. Can you hold? It also gives you an idea of what the orientation of the bridge is going to be when we get ready to open it. It's going to be a sort of a tight pinch that happens. So there will be a bridge closure associated with the opening of the structure where a lot of work will have to happen on the construction team's part to get the bridge open to public traffic. Okay, Paul, go ahead. And then tonight is going to be the first time that we see the construction lighting on the self-anchored suspension bridge. What we've done is we've loaded some images of what the construction looked like on our sister bridge, the Alfred Zampa Memorial. So this is construction footage from 2002. That's exactly what those lights looked like back then. Here's the San Pablo Bay underneath. The old bridge was open, all on Carquinez. Some still shots. So you can really see, if you hold there, Paul, you can almost fake your mind out, right? And Crockett could be Treasure Island. And you start to see what this bridge is actually going to look like. That's what we're pointing out to you today. It's the first time that you're going to see that look for the new bridge. That is the finished architectural lighting plan for this bridge. You can see string of pearl lightings on the main cable and then lighting standards that run all the way down the deck. So you're just getting a quick and early look at what the final project's going to be in just 2 years. And that's the presentation. If we can bring the lights back up. We're doing pretty good on time. So we want to go into Q&A right now. Yes?
Yeah, what size earthquake is the bridge designed to withstand, first? And second, how much can the bridge veer or move if there is an earthquake?
Okay, complex question. Basically, the bridge is designed to handle the largest potential ground motions that would happen within a 1,500-year return period. I know you're looking for a Richter scale number here, but that's not how bridges are designed. This particular bridge straddles two of the largest faults in the world, San Andreas and the Hayward Fault. So we had to go through a process of identifying what the potential motions would be in an earthquake to determine what we would build here. And ultimately, Caltrans came up with a new classification to build this bridge and the Benicia Martinez Bridge called Lifeline. And basically what that means is the level earthquake that this bridge is designed to handle would potentially disable both San Francisco International Airport and Oakland International Airport, and we would be receiving materials to Travis Air Force Base and charting them down through the Benicia Martinez Bridge that's also been built to that criteria and over this new span. So as tightly as I can get that into a soundbite, that's what we've done.
It's a lifeline.
It is a lifeline, exactly. That's what this bridge is
So for
designed.
1,500 years period of recorded history as far as earthquakes.
Most new bridges, when you build them, they're designed not to fall down in an earthquake. This bridge is designed not only to not fall down, but be immediately usable by emergency service vehicles and then return to public service without being rebuilt.
There's your sound. Part. How many lights are there? How many lights are there going to be?
Well, that's a good question. I don't know for sure.
About
There's over 100. There's 114 different strands, suspender cables. So there'll be somewhere in that magnitude, I guess, for the string of pearls. But I don't have a number.
And how many construction lights? Same thing.
I don't have the number on construction lighting, but it's in that ballpark, I'd imagine. Yes.
Why are the construction workers working at night?
Why are they on the catwalk?
Yeah.
Well, it has to do with temperature. As we pull these steel sections across, it's fine to do that work during the day and actually good to have the illumination. But with the way that the sun actually shines down on the strand, part of it's in the sun, the other part's in the shadow. It actually lengthens the strand. So you can't take a good measurement of how long the strand is. So what we do is we have the workers do that at night. So the final tensioning of the strand and the measurement taking, the surveying, happens when there's a uniform temperature around the steel. It has to happen.
Wait, say that again.
Basically, you have to measure the bridge at night because the sun strikes the cable and it heats up only part of it, and you don't get an accurate reading. So that's why workers will be working at night.
You mentioned like the cable will be kind of like a sling. Is that right? Around? Is it holding the sections together somehow, or is it just wrapping?
The cable is anchored down into the eastern side. It comes up and it wraps around the western side, and the entire cable system, the suspenders that come off of it, they're in tension. And so the deck, there's 28 different deck segments, they're in what's called compression, compressing together. Those two forces are balancing each other out with this bridge, and the weight is translating down through the towers and columns.
So it's holding itself up.
It holds itself up. Instead of a traditional suspension bridge, the main cable actually comes down and anchors into the ground. This bridge connects into the deck and holds itself up.
Making it a self-anchored,
Self-anchored suspension.
Self-anchored suspension.
Exactly.
So that's how you would describe like a normal person, why it's self-anchored.
That's a basic description of
Is
self-anchored
there
suspension.
like a, I guess, how would, just for someone who's never obviously heard of this, how would you describe self-anchored? What does that mean?
Well, first of all, self-anchored isn't a new type of design. You know, they're over a century old. There's some 30 to 40 of them around the world. This is going to be the largest one, but basically you use a self-anchored suspension bridge when you don't have as easy of an opportunity to anchor things down into the ground. Take, for example, the western spans of the Bay Bridge. That's actually two suspension bridges that are connected together at a massive anchorage in the middle. Now that anchorage has got more concrete in it than the Empire State Building in New York. So if you don't want to use all that concrete, then this is a good type of design to choose for a location like that.
So cable tension is holding it up.
Exactly.
But wasn't this done for mostly aesthetic purposes because they wanted to have something as a bold statement? You could have just built a skyway, couldn't you? All the way.
And indeed, that was one of the early proposals, was build a skyway all the way out. Aesthetics is an extremely important part of this bridge. It's a key element in making the final decision on exactly what it would be to build out here. But the first and foremost thing that we did is seismic. The reason for this bridge and this project is to deliver a lifeline structure that can potentially help the entire region and the state when that earthquake comes at some point in the future.
Bart, when the cable run starts, how long will it take to make the cable, and how many hours a day will the cable run actually run?
It will vary. So it'll continue until all of the strands are placed. What's also different about the construction process here is on a typical suspension bridge, you work on half and then you shift. since there's only one cable, the entire catwalk system is going to be working all the time. Again, that's another reason for why today is important, because we haven't started that process yet. There's going to be less of an opportunity to get out there and see this. But it will continue around the clock to some extent. And that's primarily because during the day you can pull the strands, and again, that night work has to happen where you're actually tensioning the strands to get them where they need to be and measuring the cable. Yes?
Are there any more safety measures being put in place for drivers on the current span that aren't going to get distracted by the new lights or anything? You know, are there more public information efforts going to be put out to warn people about this besides today, obviously?
Right. Well, this is the first one, basically, where we're coming out and saying that this work is happening. And we've actually been doing that all the way along as we started to lift tower segments, when we placed our first deck segments, when we felt like we might be affecting the visuals on the bridge. We put information out there because the bridge is so large, there's really no effective way to screen it. So letting people know is a big part of our safety on this. So this is the first attempt at that.
Bart, when
Yes.
do the construction workers actually begin working on the cable?
We expect, well, it's already started really, because they're placing the catwalk system and the hardware. And the actual beginning of the work for the cable itself is expected early next year, possibly January 2012.
So we won't see construction workers on the catwalks for a while.
No, starting now, they're already up there.
Okay.
Yes. Because what they have to do basically is they have to put all of that hardware up there. They're going to build a ski lift on top of that catwalk, and they're going to put these things called cable formers that look like giant forks that will hold the strands as we pull them across. So they have to do all that work first. That's why we won't get to pulling the strands until early next year.
Bart, where are these strands being manufactured?
The strands came from Pujang Cable in China. Yes.
You're going to have a walkway so people can walk onto Treasure Island. Is that part of the plans?
Off the final bridge, there's a bike and pedestrian path that will be landing in Yerba Buena. Yes.
Any possibility of expanding that to San Francisco?
The Metropolitan Transportation Commission is doing a study on that very thing right now.
So there's a possibility.
There is a possibility.
But no one can go like up to the top the way we are.
No, there's not going to be public access to the top of the tower of this bridge. This is a very unique opportunity that we're doing today.
The pieces
Yes.
that,
On the next year, the opening of the westbound detour, could you talk a little bit on how that will happen? Will there actually be, will it happen kind of last time where there really wasn't that much disruption to motorists? Or will there be some period of hours or a day where people cannot go on the bridge or a portion?
Well, that actually is going to be big news, Randy. We're telling you right now that we are going to be closing the westbound portion of the bridge early next year, probably sometime in the spring.
But for how long?
We're still working on that right now. We're going to have to come back to you with a very specific presentation on exactly what's going to be happening there. It's probably going to be a couple of days that we'll be doing this work, because we're going to be restriping that whole approach coming out of the toll plaza there. So again, we'll come back to you, Dennis, with more information, but it's probably a couple of days. Westbound will be closed. We'll be working with our transportation partners throughout the region, like we do whenever we have to close the Bay Bridge, and that's not too often.
Is there a holiday around that time that you guys can pick that use the pain?
Fingers are crossed that we will find such a holiday, but the things that have to happen basically is we have to be ready from a construction standpoint to do the work, and we also have to have the weather available for us so that we can get the right type of strike.
But it might be possibly up to a couple days that just the westbound portion of the bridge?
Just the westbound, just heading into San Francisco. Eastbound will remain open while we do that work, and we'll come back with more information soon.
You mentioned that the cable strands were made in China. Can you talk about what else was made in China that is going into this bridge and how the work over there overall went?
Sure. Well, there are actually a number of countries and U.S. states that have participated in fabricating elements of this bridge. And so, as far as the self-anchored suspension bridge is concerned, the deck sections that are arriving today, all of them were fabricated at ZPMC in Shanghai, China, as well as the tower sections for the main tower. And then Pujang Cable, also there, different company though, fabricated the strands for the main cable. These saddles that these actually sit in at the top of the tower, the deviation saddles you saw at the end, and the ones on the eastern end were fabricated in Japan at Japan Steel Works. The The saddles for each one of these 114 different suspender cables were fabricated in the UK at Goodwin Steel. If you look at the entire eastern span, we have most of the piles and the foundations, these massive footing boxes that the entire bridge sits in, come from exotic places like Vallejo, California, and Corpus. See, I can say that because I'm a native Vallejo. Corpus Christi, Texas, for the footing boxes, and also up in Oregon and Washington. So there are a number of different places that contribute to providing different structural elements. If you're looking at steel, in particularly, there's more domestic steel in the entire eastern span than any other foreign steel component. And if you look at the final bridge, a little over 75% of the steel for the eastern span, the bridge that connects from Yerba Buena Island to the Oakland touchdown, is fabricated in some U.S. steel.
Hey Bart, is there an updated cost to the total price tag for this project? Or are you still talking about, is it $6 billion when all said and done 2 years from now? Or is that still the...
Yeah, the way, it's about that, 6.3. And the way that you can chart that is the Toll Bridge Program Oversight Committee, which consists of Caltrans, the Bay Area Toll Authority, and the California Transportation Commission, puts out regular reports that basically says how we're doing financially. Along with that, there's $900 million contingency that's part of the project fund. So that's all updated within that report. It's downloadable from the Bay Bridge Info site and from MTC's website, or BATA's website.
Are you shooting for June 2013 now, or what is that?
Late 2013 is when we expect the bridge to be open.
So more like November, not summer.
Well, it depends. It's very hard to put a date on exactly when this bridge is going to be completed. The September, November time frame, I think, is what you'd potentially see if you look in that report. But we are doing everything we can to get the bridge open as soon as possible. And if we have the opportunity, we'll open it as early as we can. But 2013 is when we'll open.
Is the America's Cup something you guys are taking into consideration with trying to, or just when it opens, it opens?
Well, I think when it opens, because seismic safety is the primary concern for this bridge, but we are going to be working very closely with the America's Cup. Obviously, as we mentioned in the presentation today, it will be a full bridge closure associated with the opening of this bridge. So we'll be working with the entire region and probably the state when that time comes, and America's Cup as well, because I know they're expecting a number of folks in the region for those races. So we'll be working closely with them. But again, seismic safety is the primary concern of this project. It'll open when we're ready.
Those deck cases that just came, did they get here yesterday, or when did they end up coming?
They arrived yesterday.
Have there been any fatalities or serious injuries so far in the construction of the bridge?
So far on the eastern span projects of the Bay Bridge, we have not had a fatality. Safety is a prime concern for all of our contractors. I'll knock on wood as I say that because it's something that we take very seriously and we hope to continue.
And 33 people died on the building of the old Bay Bridge.
Very different times with the building of the old bridges. A lot of safety implementations have happened since the 30s, but yeah, something like that.
How many commuters use the bridge?
280,000 vehicles go across the Bay Bridge every day on average. It's one of the top 3 busiest bridges in the nation, making it one of the busiest bridges in the world. Yes?
Just to confirm, can you tell us when did construction start on the bridge? And also going back to the videos that were shown earlier, are those both the video of the steel coming through under the bridge and the archival video from 1930? Is that both in the media bar?
Both of those things are in the media bar and downloadable. That is the shipment arriving yesterday, the one clip that you saw in the presentation, and that's there as well, right, Paul? So you can download that. What was the other part of the question?
Oh, just construction.
Oh, when did construction?
When construction began, obviously comparing it to when it's going to be finished right now in 2013.
Okay, so keep in mind, the Bay Bridge is actually a series of mega projects. I know the public think of it as one bridge, as do we. It's approximately 8 miles long when you think of it that way. But when our projects basically began was about 2002 with the construction of the 1.2 mile long Skyway.
Just looking at this, the tons of steel for the, is that for the whole thing, the 8 mile long, or is that just this?
Can you tell me what you're looking at?
The SAS specs.
That's just for the self-anchored suspension bridge.
Okay,
so what we did with that fact sheet is put facts at a glance for the self-anchored suspension bridge portion alone. Now, keep in mind, the SAS is what, 2,047 feet? Is that what we said? Mm-hmm. All right, so I got that right. So that's as long as it is. The entire eastern span is 2.2 miles long. It's made up of an Oakland touchdown, a skyway portion, a Yerba Island transition, and then the tunnel. And then we have the other spans on the western side that were retrofitted through the mid-90s and early 2000s. So the Bay Bridge proper, from the Maze area all the way out to the 5th Street ramps, is 8 miles long.
Any idea like how much steel all that would be, the whole thing?
How?
Like,
Did I just say
put
no?
into this project?
That would be a lot
Okay.
of steel. I know we have a quote there for how much steel is in the self-anchored suspension
Right.
span in the order of like 60,000 tons or something
Yeah.
like that.
Hey, Bart,
Yes.
how many construction workers are working on the project?
It varies depending on time. It is thousands literally when you look at at all of the projects together. At any one time, we can have a couple of hundred working in any location. That's what you see right now with the folks here at Pier 7 and out there on site. Any other questions?
I didn't quite understand how you guys measure the seismic safety factors.
Most folks, when they say what can this bridge withstand, they expect a Richter scale number. But that's hard to get when you're building a bridge because the bridge is horizontal, and Richter scale sort of measures an epicenter at one location. So what we did is we analyzed what the potential ground motions would be in a large-scale earthquake that would be epicentered either on the Hayward fault or the San Andreas fault. And by projecting that forward, we were able to calculate and design what we ultimately would build for this bridge. So there were things that we had to innovate that did not exist before to meet the criteria that we set for ourselves. And you can look at those on our website, and I'm happy to talk to you about them offline. Any other general questions? Okay, thanks everybody.
So Bart,
Yeah.